power electronic circuit or power converters. That means these are the circuits which are used to convert the power from one to other. That means we have AC and here is the DC. To convert AC to DC and to convert from DC to AC and to convert from higher AC to the lower AC, that means high voltage AC to the low voltage AC, and to convert from high DC to the low DC or low DC to high DC, anything. This can be anything. For this conversion we use the power electronic circuit. One thing we have to remember, for regulators or AC voltage controllers we use this power electronic circuit. Also we use this in AC voltage regulators. Okay, let's discuss one by one. First one is the phase controlled rectifiers. Phase controlled rectifier. This circuit converts AC to DC. This phase controlled rectifier means, in simple words, this is our charger, wall charger. It converts AC supply to the DC supply. Here you can see the ratings. You can see input is 100 to 240 volt AC. Output is 5 volt DC. So this is a phase controlled rectifier. And here the main function of this phase controlled rectifier is fixed AC voltage. It converts fixed AC voltage to the variable. It means we can get anything, any voltages like 5 volt, or if we design this phase controlled rectifier for 6 volt or 12 volt, any voltage we can get. So it's a variable voltage, low ripple. Ripple means the AC content in the output, it should be less. If ripple factor is less, then efficiency is more. So it should be low ripple DC voltage. This is the main function of the phase controlled rectifier. It basically includes some diode rectifiers, single or three phase controlled circuits. Yeah, it may be single phase, it's a single phase, and three phase also available, from three phase AC to DC, that's also available. So it's another function is, that means it's made of some diode rectifiers. You know those diode rectifiers, that's full wave rectifier and half wave rectifier, all those things. It's like here is my AC source and here is our transformer, step down transformer. Okay, step down transformer, and from this the diodes are there, P and N. This is a half wave rectifier. Here we need to give the load. This is the half wave. In that way, full wave rectifier, bridge rectifier, all those things are used to make the phase control rectifiers. And next one is the choppers. Choppers, choppers. It converts DC to DC. If I have high voltage DC, and these choppers can be used to convert this to the low voltages. Its main function is fixed DC voltage to variable DC output voltage. That means if I have 12 volt DC as input, I can convert this 12 volts to variable DC output. That means I can convert this to 5 volt or 3.3 volt. There are some standard voltages, 3.3 volt or any voltage. We can convert that to any voltage. So it's a variable DC output voltage. And the components used in these choppers, they include like IGBT, GTO. IGBT means insulated gate bipolar junction transistor. We will discuss more about that in later videos. GTO means gate turn off tie resistor, and power MOSFETs. These are all some of the components used to make these choppers. IGBT, GTO, power MOSFET, MOSFET. These are all the various things used to make these choppers. Remember this, choppers, which converts DC to DC. Okay. Then next one is the inverters. Inverters. I think you know this inverter. It converts DC to AC. That means fixed DC voltage to variable frequency or fixed, not or, and fixed or variable magnitude AC voltage. AC means it should have frequency and the magnitude, two things. So inverter converts fixed DC voltage, have a fixed voltage, let's say 24 volt DC, from this to variable frequency. That means 50 hertz or 60 hertz, like that. In India it's 50 hertz, in USA it's 60 hertz, like that. Variable frequency, fixed or variable magnitude AC voltage. That means 220 volt to 30 volt, like slight variations. That's the function of this inverter. It converts DC to AC. Inverter. Remember this, DC to AC. And next one is cyclo converters. Cyclo converters. Cyclo converters means AC to AC. Just convert the AC signal to the AC signal. The main function is AC at one frequency. Let's say the frequency of this AC be 50 Hz. Okay. This is the AC current at 50 Hz. One frequency to the AC at different frequency means lower frequency. Basically it converts the cyclo converters means high AC source to the low AC source to the AC at different frequency. Converts low. Remember this, lower frequencies. High AC voltage or the frequency, different frequency of lower voltage. That's the cyclo converters. Next one, last one. Okay, this is the AC voltage regulators or AC voltage controllers. AC voltage controller or AC regulators. It converts fixed AC voltage to the variable AC voltage. Fixed AC voltage to variable AC voltage. This is same as the fan regulator. We have in fan we are supplying 220 volt for that fan regulator, and we have steps, step 1, step 2, step 3, 5 steps are there. That means this is a fixed AC voltage. It's converting to the variable AC voltage. That means 190 volt, 200 volt, 210 volt. So the fan speed decreases when this voltage decreases. So in fan controller we are using this AC regulators. Remember this, AC to AC converter is the cyclo converters and this is the AC regulators. Now you have to tell for which this belongs to. That means it converts 230 AC to I think it's 9 volt AC, AC to AC. Which category it belongs? It belongs to cyclo converters. Then here I am supplying 12 volt DC supply. From the 12 volt, here you can see here 3.3 volt and 5 volt. 12 volt DC is converted to 3.3 volt or 5 volt. Something is there here. What's that? That's the chopper circuit is there. So it converts DC, fixed DC voltage. Here I am giving 12 volt fix or 9 volt constant, but I am getting 3.3 volt, 5 volt, all those things. That's the working of the chopper circuit. Thank you.